Okay, let's finish the types of bonds. So covalent bonds we've talked about are unequal sharing of electrons. The electronegativity difference between the atoms will be between 0 and 0.4. They're usually identical atoms. And the polar covalent bonds do not share the electrons equally. These will have an electronegativity difference between 0.5 and 1.7. One atom is slightly negative and one atom is slightly positive. So here we have fluorine and hydrogen, and you can tell by the shape that one has a lot more electrons around it, and this end here is going to be, the fluorine end is going to be slightly negative and the hydrogen end will be slightly positive. And when one atom has slightly more negative end than the other, this is known as a dipole. And this where we get this funky little S number 8 shape. The funky number with the plus indicates a partial positive charge, and that symbol with the negative will indicate a negative charge. Hence, here would be an example of hydrogen would be here, and chlorine over at this end. So comparing ionic and covalent bonds. When a bond is nonpolar, you can see everything seems to be distributed evenly. It's very symmetrical in shape. When it becomes polar, we tend to have a less symmetrical shape, and one end tends to be more negatively charged and the other is more positively charged. With ionic bonds, they really aren't connected to each other at all. They're separate, the positive versus the negative. So in summary, when we're looking at the electronegativity difference, for a covalent bond and the electronegativity difference is between 0 and 0.4, we would have a nonpolar covalent bond. When the difference is between 0.4 and 1.7, we would have a polar covalent bond. And any electronegativity difference between 1.7 and higher would be ionic. So metallic bonds, the difference between metallic bonds and the others are that these are between two metals, and they tend to be of the same metal. And what makes it so conductive for electricity is that we have all these electrons that are free to move around. So let's look and do some practicing. Which formula represents an ionic bond? And if we recall, ionic bonds are between a metal and a non-metal. And if we look through here, the only metal is calcium, so the answer would be D, calcium chloride. The bond between hydrogen and oxygen in a water molecule is classified as what? A covalent nonpolar, ionic and polar, ionic and nonpolar, or covalent and polar? Well, polar and nonpolar has absolutely nothing to do really with the ionic compounds. So that leaves us with A and D. And between hydrogen and oxygen, they will not be shared equally. So therefore, the answer would be D. It is a covalent polar bond. And you can verify that is correct by looking at your electronegativity and looking at the difference between oxygen and hydrogen. So let's check our understanding. The electrons in a bond between two iodine atoms are they shared equally, resulting in a bond that is polar, unequally, therefore it is a polar bond, unequally resulting in a bond that is nonpolar, or equally and resulting in a bond is nonpolar. Well, first off, knowing that they're both the same atoms, we will say that they will be shared equally, so that leaves us with B and D, and the resulting bond, would it be polar or nonpolar? If it's identical, then it would be nonpolar. So again, the answer would be D.